All right, good morning, everybody. Let's finish up the semester by just doing chapter 6. We have two sections, and they both deal with solving something called systems of equations. When we talk about systems, we're talking about two or more equations with two or more variables. We talked about this earlier in chapter 2, or actually in chapter 1. When we talked about how two linear equations can or behave with each other. We looked at these possibilities. Where this is line 1, this is line 2, line 1, line 2, line 1, line 2. These are examples of systems where we have two equations, and each of these have two variables. It looks like sort of like this: x equals 3x plus 2, and x equals 5x minus 1. Those are two systems. We have one system here, and we have another system here. So it's a system of equations. Now, in this chapter, it's the same principles apply. Solutions are where the lines intersect or cross. So in these, the first one, they have zero solutions. There's no solutions. We call those lines parallel. Remember, we said that if they have the same slopes but different y-intercepts, then they're parallel. And the symbol we use for parallel lines for that. And it has no solutions. Then we look at this line. This example here, they have an infinite number of solutions. Those are the same lines. Line 1, line 2, so every point is an intersection. So this is the first part here on the left-hand side is a distinction between no solutions and infinite solutions. This right-hand side, we have what are called parallel, and this one is parallel line, or perpendicular, I mean not parallel. Perpendicular. And that symbol looks like this. And it only has one solution. So it has one solution. This one here, is there any others? It has one solution where they intersect. And the only thing that these things have in common is the slopes are not equal. The slopes are not equal. But the difference between perpendicular and any other is that the slopes are negative reciprocals of each other. Review back the notes when we talk about perpendicular lines there. All right, so now, depending on whether these graphs intersect or not, or if they could go from parallel lines to the same line, we have names for those. We say that they're consistent if they have one or more solutions. This is consistent. This one's consistent. This one's consistent. However, parallel lines, since they don't intersect, are called inconsistent. They have nothing in common. So it's inconsistent. If they have zero solutions. So that's the first part, dealing with number of solutions. Then we talk about being dependent or independent. Those, once you think about those, they make more sense. If it's dependent, then it depends on another equation. So dependent lines are lines that can become the other line by algebraic manipulations. So in other words, like this one here, the same lines are dependent. Because deep down, an example of dependent, which would be x plus y equals 5. Or if we have negative 2x minus 2y equals negative 10. On the second equation, line 2, we can factor out a negative 2. Factor out a negative 2, we get the same thing as the other line. So they're the same thing, they just have a common multiple between them. So if they eventually become the same equation, they're dependent. If not, they cannot become the other equation. So all these other ones are independent. Right. So those are the terminologies we need to deal with in this section. So far, we know 3 methods to solve systems. The first one, we can do it by graphing. The second, we can do it by substitution. The third, by a process called elimination. All right, so let's look at an example here. Let's do a simple one. X minus y equals 5. 2x plus y equals 1. We'll first look at graphing. Now, the major problem with graphing is you have to make sure that your graph is equally spaced. all these little lines, little indices have to be exact. So we have line 1, which is x minus y equals 5. Solve for y. So move the y over there and the 5 there. So we get y equals x minus 5. We added y to both sides. We subtracted 5. So now we graph this one. So it says here we have y-intercept 1, 2, 3, 4, 5 at -5. And the slope is 1 over 1. 1 and 1. So there's that line. Then we look at line 2. 2x plus y equals 1. Move the 2x over, so we have y equals minus 2x plus 1. The y-intercept is positive 1. The slope is negative down 2 over 1. And connect them. And you see the problem. Unless we have rulers and everything else, we're dependent on what we see here. So I'm thinking that the closest we have is going to be that. It's actually down here. So we're saying our solution is 2, -3. If not, then it's 2, -2. We'll try that. All right, so that's graphing. Only as good as the graph itself. Same equation. We'll do something called substitution. We have line 1 is x minus y equals 5. Line 2 is 2x plus y equals 1. Here are the steps. First step. Choose either equation, L1 or L2. Choose either variable to solve for. Let's see this. So in my first step, I'll look at line 1 because it's easiest. I chose line 1. This is step 1. So it's x minus y equals 5. Step 2, out of these two, I'll go ahead and choose x. So I'm solving for x. So I get rid of the y. X is equal to y plus 5. We'll come back to this one later on. Third step. Plug that equation into the other line. Since we used line 1 here, now I take, in step 3, I take line 2. 2x plus y equals 1. Now, anywhere I see an x, I put a y plus 5. So it becomes 2y plus 5 plus y equals 1. So I plug that equation into the other line. Then solve for the remaining variable. I have one line now with only one variable. So I solve for y. So I have 2y, 2 times 5 is 10. Combine like terms. 3y plus 10 equals 1. Subtract 10. 3y equals 10's bigger, so it's negative. 10 minus 1 is 9. Divide by 3. Negative 9 divided by 3 is 3. So y is equal to 3. Plug that solution into the equation from step 2, which is this one here. And solve for the variable. So this equation here says, this is step 5. X equals y plus 5. I know that y is equal to negative 3. So x equals positive 2. Your solution is where those values align. So your solution is the answer is at x, y, which is 2, negative 3. Which is what our graph, what this one's supposed to set, it did 2, negative 3. But unlike the graph example, we didn't have to guess. This one is what it is. So that's the substitution method. All right, let's look at the last one. The third, actually, the third one is one more after this. This is called the elimination method. They use the same equations. Line 1 is x minus y equals 5. Line 2 is 2x plus y equals 1. And here are my steps. Put both equations into standard form. Remember, standard form from chapter 1 or chapter 2 was you have the x's and y's on the same side. That's standard form. Check. They're both that way. So here's step 1. We have them both that way. Now, second one is choose either variable to eliminate. After adding the two lines together. Okay, now what we need to have here, they have to have the same coefficient, but they have to be opposite in sign. Like, for example, here, we see that this has a negative one and this one has a positive one. The same number, different signs. We could just use that one, but that's too easy. So let's say in this one here, I'm choosing a variable. I'm going to choose X. So step 2, I'm choosing X to get rid of. Now, what you have to do here, sometimes you may have to multiply, change one equation or change them both. So what I need to have here in front of this X, or one of these, it has to have, this is a positive 2, the other one has to be a negative 2. So I have to take that first equation and multiply each term by negative 2, because I need to have a negative 2 in the first spot. Okay, so negative 2 times X is negative 2X. Negative 2 times negative Y is a positive 2Y. Negative 2 times 5 is negative 10. That's line 1. This is line 1. This is line 2. And leave the second line alone. 2X plus Y equals 1. Third step. Add the two lines together. Because what should happen now is one of these variables should disappear. And sure enough, negative 2 and 2, we have 2Y plus Y is 3Y. Negative 10 plus 1 is negative 9. And solve for the variable, the only variable. So Y is equal to negative 9 divided by 3. Now, since this process, we took both of the equations and dealt them together as we went through, what we can do in step 4 is plug that solution into either of the original lines and solve for the remaining variable. So I'm saying that Y equals negative 3. I come back here to the originals, and let's pick line 2. I choose line 2, which is 2X plus Y equals 1. Anywhere I see a Y, I put a negative 3. So it's 2X positive, negative, negative. I have to solve for X now. So add 3. 2X equals 4. Divide by 2. X equals 2. And that's your solution, if it exists. So my solution is 2, negative 3. That's where the two lines intersect. All right, let's go ahead and try a little bit more ugly ones. Let's try some tricky ones. The graphing one we're not going to do because, again, graphing one only works if you have proper graphing material. So we're only going to do substitution and elimination here. The equations we have are 4X plus 3Y equals 11. Line 2 is negative 5x plus 2y equals 15. So the first we're going to do here is substitution. So in substitution, we choose one of the two lines. So step 1, let's do line 2. Choose line 2 and solve for a variable. So we have negative 5x plus 2y equals 15 and solve for y. So we're solving for y. So move the 5x over there. So we have 2y equals 5x plus 15 and divide by 2. So to find our y value, we have to use that equation. But since we used line 2 in this first step, we now have to take line 1, which was 4x plus 3y equals 11. And anywhere we see a y, we put this equation. So we have 4x plus 3 times 5x plus 15 over 2 equals 11. Now we got to solve for x. That's the only variable. So we have 4x. We'll distribute to 3, which becomes 3 times 5 is 15x over 2. 3 times 15 is 45 over 2. Because it's a monomial, I can split them up. All right, we have fractions and equal sign. So we got to do those 5 steps. Find the LCD, which is 2. Multiply each term by the LCD. So we have 2 times 4x, 2 times 15x over 2, 2 times 45 over 2, and 2 times 11. So we found the LCD, which is 2. We multiplied each term. This is a term, that's a term, that's a term by the LCD. Reduce to get rid of the denominators. Nothing there. This 2 and that 2 cancel, leaving me with 15x. This 2 and that 2 cancel, leaving me with 45. It goes 2 times 11. Multiply to get rid of the parentheses. 2 times 4 is 8x plus 15x plus 45 equals 22. And then solve. These are the same 5 steps we've been using since day 1 of the semester. Solve for x. 15 plus 8 is 23x. Move the 45 to the other side. 45 minus, so 45 is bigger, so it's negative. So we have 45 minus 22 is 23. Solve for x, divide by 23. So x is equal to -1. So that's my x component. The y component, is up here. So I take that and these and combine them. So y is equal to 5 times -1 plus 15 over 2. 5 times negative is -5 plus 15 over 2. 15 minus 5 is 10 over 2. So y is equal to 5. So the answer is at -1, 5. We have an intersection. That's using substitution. Let's do the same equation using elimination. So we have 4x plus 3y equals 11. Negative 5x plus 2y equals 15. So elimination. First step. Which variable do we get rid of? Well, since these are opposite signs, I would eliminate x. So in order to get rid of the x, I need to have the same number, but different signs. So for this one, to get the same number in front, I have to multiply 5 to the first equation. And the second one, I have to multiply by 4. Because now you'll see, because they have opposite signs, 5 times 4, 4 times 5, both going to give us 20. So it's going to be 20x plus 15y equals 55. 4 positive and negative is negative. 4 times 5 is 20. X. 4 times 2 is 8y. 4 times 15 is 60. So that gives us 20x plus 15y equals 55. Negative 20x plus 8y equals 60. So 5, 15, 55, 8, and 60. Okay, so now I add the two lines together. X's cancel. 15 plus 8 is 23. 55 plus 60 is 115. Divide both sides by 23. And it equals 5. 23 times 5, 15, carry the 1, 10, 11. So now, since I know what y is, I can go back to the original equation and I could solve for the x variable. So I pick either one, doesn't matter which one I pick. Let's pick the second one. Normally I'd pick the top one since it's already positive, but I'm gonna do this one. So I am picking negative 5x plus 2y equals 15. In place of y, I put 5. Now I've got to solve for x. So it's negative 5x plus 10 equals 15. Subtract 10. Negative 5x, 15 minus 10 is 5. change the signs. So I have 5x equals -5 and divide by 5. So x is equal to -1. So my answer is at -1, 5, which is what we got here also. All right. So that's how you do, and you can choose whatever method you want whenever you need to. Let's look at some special situations on these. So we'll look at both elimination and substitution. So we have x minus 3y equals 1 and -2x plus 6y equals 5. This is line 1. So here we're going to do substitution. And here we'll do elimination. So in substitution, I got to pick an equation. So I'm picking line 1, x minus 3y equals 1. I want to solve for x. So I got to move the 3y. So equals 3y plus 1. So there's my equation for x. Now I got to use the other line, line 2. Anywhere I see an x, I put that variable in there, or that equation. So to -2, x is equal to 3y plus 1 equals 5. Let's solve for y. Get rid of the parentheses, so it's -6y minus 2 plus 6y equals 5. -6 and positives cancel. Because these don't equal, there's no solution, meaning the lines are parallel. Whenever something like this happens, you can't go any further. We know the lines are parallel because they have no points of intersection. All right, so let's look at elimination. So our equations are x minus 3y equals 1, -2x plus 6y equals 5. Remember, for elimination, I need to have the same coefficient but different signs. So since this one's 1, what if we multiply the first equation by 2? Okay, 2 times 1 is 2x minus 6y equals 2. And the second line is -2x plus 6y equals 5. Once we add them, that doesn't equal, so no solution. The lines are parallel. So if you get to a point where the numbers don't equal, all the variables are gone, and you have numbers that don't equal, then you can't go any further. All right, so let's look at the other. So this is one for parallel. Let's look at an example for perpendicular. What it would look like. And we're going to do both things here. We're going to do substitution. And then elimination. The equations are 2x plus 3y equals 6 4x plus 6y equals 12. So this is line 1, this is line 2. Substitution, then we pick line 1. I'm gonna solve for x. So I subtract the 3y from both sides. 2x equals negative 3y plus 6. And divide by 2. Okay, so we solved that one there. Now we got to plug that into line 2. Line 2 was 4x plus 6y equals 12. Anywhere I see an x, I put this entire equation. For negative 3y plus 6 over 2 plus 6y equals 12. The 2 and the 4 cancel. So we distribute. So we got negative 6y plus 12 plus 6y equals 12. The 6y's cancel. Since 12 equals 12, no matter what, then we know we have infinite solutions. Any x and any y will be a solution. They're the same line. It's more evident here in elimination. We have 2x plus 3y, equals 6. 4x plus 6y equals 12. Let's get rid of the x. So we have to multiply negative 2 to get the negative 4. So that gives us negative 4x minus 6y minus 12. If I add them together, everything cancels. So that means infinite number of solutions. They're the same line. Okay, so those are special circumstances. If all the variables disappear and we get different answers, negative 2 and 5, then we know they're parallel. They have no points in common. If they equal each other, or if they both become 0, then they're the same line. Infinite number of solutions. All right, let's look at two word problems. Example 6. These are application problems. It says, at Max's Munchies, caramel corn worth $2.50 per pound is mixed with honey roasted mixed nuts worth $7.50 per pound. In order to get 20 pounds of a mixture worth $4.50 per pound. How much of each was used? Okay, we have two variables here. We have to worry about one variable is the weight. WEIGT. And then the second one is the cost. So what we have here is we have, let's call the X is equal to corn and Y is the nuts, the mixed nuts. So what do we know? We know that if we take the corn plus the nuts, then we get 20 pounds. Now, what do we know? What else we know? We know we take X number of corn that cost $2.50 and we add it to $7.50 of the Y amount, then we get $4.50 of this 20-pound amount. So $2.50 of this much plus $7.50 of this much gives us 20 pounds that cost this much. So let's see what we have here. We have X plus Y equals 20. 2.5x, 7.5y. 20 times, so 2 times 4.5 is 9. 9 times 10 is 90. We can get rid of the decimals. We can get rid of the decimals if we multiply by 10. So that gives us 25x plus 75y equals 900. It's much easier because we don't have decimals. Okay, let's get rid of one of them. Let's get rid of the x, it's smaller. I'm going to use elimination. So to get rid of this x, this is a 1, I need to multiply the top equation by negative 25. So I'll multiply the entire top equation by negative 25. That gives us negative 25x minus 25y equals negative 500. So the top equation is negative 25x minus 25y equals negative 500. The second line is 25 plus 75 equals 900. Add these two lines together. The x's cancel. 75 minus 25 is 50. 900 minus 500 is 400. Divide by 50. Zeros count. 5 goes into 40 8 times. So we know what y equals. Now we plug this into one of these. So I take the first equation. Anywhere I see an X, a Y, I put an 8. So I have, and I move the 8 over, X equals 12. This is 12 pounds, and this is 8 pounds. So we have 12 pounds of the corn, and then we have 8 pounds of the mixed nuts. And that's what we're looking for. All right. That does it for that one.